we will discuss on how to set multiple choice questions. I may take approximately 30 minutes to do that. Then we can have some discussions. We will learn from you also how to do this. What is a multiple choice question? Basically, the multiple choice question has got a a stem, which is called the problem, a list of suggested solutions, which are called alternatives or options, and the right answer, which is the key. So these three form the multiple choice question. The stem of the MCQ may be in the form of a question, or it could be in the form of an incomplete statement, or filling a missing word, or it could be a basic scenario or a case study. I will explain what is scenario and case study later in the course of the discussion. The stem should be meaningfully presented. It should have a definite problem. I have a small example to tell you what we mean by definite problem. For example, if I want to ask, why is the unit of X-ray energy is kV, which is not the right way to ask in my opinion, right? Even though we use kV, but that is not what I want to test the student by asking the question is more important here. That is the learning objective or the learning outcome. Why is the unit of X-ray energy is kV is better if I ask the energy of Bremsstrahlung X-ray beam is denoted by the applied voltage and not by kV, because then it gives the student much better understanding of the question. The question is very definite. What I want to know is, for Bremsstrahlung, we don't use KEV, we use KV. Whether the student knows that and the reason for that. But if I put this question the previous way, the student will not understand. So the question should have a definite problem. When that you have in your mind should be translated properly. Avoid irrelevant materials in the STEM. Some people, we used to have the over enthusiasm and give more information to the student. For example, I have given a thing, data on the dose distribution in the penumbral region of megavoltage X-rays are important for radiotherapy planning systems. And then I say the radiological penumbra of a radiation beam is measured as the. So the first part of the STEM is not relevant at all. It is not going to be helpful for the student neither. So it is enough if I say the radiological penumbra of a radiation beam is measured as the, then the option 1, 2, 3 or A, B, C, D. So we should avoid having irrelevant materials in the STEM. Next, the STEM should be negatively stated only when significant learning outcome requires it. For example, usually there is a study which says students often have difficulty in understanding items with negative phrasing. And I will say a little more on it later also. If a significant learning outcome requires a negative phrasing, you are welcome to use it. But you have to make sure the student understands that question has a negativity in it. For example, I'm giving an example here. The following are the disadvantages of using deep X-ray therapy. Except, the reason I'm using this question, I want to be negative here, is because there are more than one disadvantages, whether the student knows all the disadvantages or not. Whether that is my expected learning from the student. So there I can allow to use, but I have to make sure the student understands I'm looking at a negative thing. I have to make it bold or italic or capitalize it. So this is very important. That is very clearly stated in all MCQ things. And avoid negative questions. Totally avoid. Try to avoid saying which of the following is not true. Right. This you can easily avoid. But in case you want to have it, then the not has to be larger, bold, or whatever. The problem in this, it is very tempting for us to use it because it is easy to do such questions. But they can be confusing the student. More importantly, are liable to be abused as a student may not be able to find a correct answer without really knowing the correct answer. He may give a correct answer without really knowing what is the correct answer for it. You really don't test what you want to test there. The STEM could be a question or a partial sentence. For example, I take the same question again. Why the energy of Bremsstrahlung X-ray beam is denoted by the applied voltage kV or not keV? It can be in a question form. Or I can say the energy of bremsstrahlung X-ray beam is denoted by the applied voltage and not keV because it's an incomplete statement. So you expect the student to complete the statement. So you can have either of these ones. Phrase your question as simply as possible. As I said earlier, completely avoid negative thing. Here the idea of when I say phrase it as simply as possible, the reason is your idea is to test the student for the learning objective. You have something in mind, test the student's knowledge of English or his comprehension. So try to make the question as simple as possible and don't give any clue to the student. Avoid using double negatives. Totally, this is not and then again a negative. Totally avoid using double negative and don't give any irrelevant details that will put the student totally out of the context. So try to be very careful on it. When you frame a question, it has to be as simple as possible and avoid the double negatives. Don't have extra statements or extra words in it. The STEM should tell you what you want to test, and for that, how do you frame a question? For example, here, this is just an example I put. You can have different examples. I want to test the student should know two things from this question. One is when you change the SSD, the inverse square law should be applied. Second thing, when you apply inverse square law for an output, you have to know that the output is always stated at Dmax. So here, you can also call it a tricky question, but there is a learning objective which I want to test. The beam output at Dmax for 80 centimeter SSD of a cobalt unit is 160 centigrade. What will be the beam output if the treatment is to be performed at 120 SSD? Usually the student will do 80 square by 80 plus Dmax. I said cobalt, so it has to be 80.5 and 120.5. So I want to test whether the student knows that particular point, that the output is stated in Dmax, and that makes a difference in the calculation. And use multiple answer stems only when absolutely needed. See, this is another thing. Particularly, I was a little disappointed when I was preparing for it because I like these type of questions. That is, I have more than one correct option and I put them in the stem itself, right? It is in the question itself. And I say, for example, here you can look at the following are potential solutions to reduce contribution from scattered radiation in CBCT. Anti-scatter grade, scatter reduction algorithm, filters, optimization of acquisition modalities. I can say I have given 5 options. 1 is alone correct. 1 and 2 are correct. 1, 2 and 3 are correct. 1, 2 and 4 are correct. And 1, 2, 3, 4 are correct. Actually, the MCQ setting methodologies says avoid this as much as possible. So you can use this only if it is going to really help you to bring out the learning outcome of the student. And I would also add, suppose if you're preparing 50 questions, keep this maybe to 5 or maximum 7-8%. Don't have too many of this type of questions. Keep specific content of item independent of one another. This is actually a thing for chief examiner rather than for the examiners, because in our case, the chief examiner is going to pool all the questions, right? And take some of them. So one has to be very mindful of one question not leading to the answer on the other question. For example, I have got 2 questions here. The first one is the following are true for percentage depth dose except. Here, let me assume the student doesn't know the answer for it. What happens to the percentage depth dose? It decreases with this, increases with energy and all. And the next question I ask, the PDD for 10 centimeter depth at 10 centimeter depth for 80 centimeter is this much. What happens if it becomes 100 centimeter? When he does this problem, he knows one answer for this one, for the other question. So one question answer or the question should not lead to the answer for another question. So when you prepare also, you please remember your set should not be that if when the person does one, okay, this answer will help me to answer another question. That should not be. Then you are losing one question totally. Have a case study and ask multiple questions. This is something you can do. You can have one case study and have multiple MCQs below this, 2 or 3 or even 5. But this has to be done only 1 or 2 in your set, not many of them. For example, I give an example what do I mean by case study and having multiple questions. Here is a case study. A physicist calibrating a cobalt unit in a hill station at an altitude of 1,000 meters did not have a barometer to check the pressure. He called the airport to note the pressure, and the airport gave him sea level pressure, and he was at 1,000 meters. If you give this case study, you can even elaborate it a little more and ask multiple questions. For example, in this, I can ask, what is the approximate change in pressure for 1,000-meter height? The physicist should know what is the change in pressure for this, right? And what is the percentage error in his output calibration because he is using a sea level pressure instead of 1,000 meters? What will be the percentage error? You can also ask how much this error in the output would have, how it will affect the patient treatment, whether it will give extra dose to the patient or it will give less dose to the patient. So from one case study, you can frame more than 3 or 4 questions. This is one method of asking, but limit it to 1 or 2 in your set. Don't have everything, but it is interesting to do this. It will be helpful for the learning outcome. Do not include keywords in the STEM that can give clue to the correct answer. I'm giving a very good example for this, how the keyword helps. You look at this question, the output factor is measured in the same reference geometry and depth as that used for measurement of backscatter factor, tissue phantom ratio, output of external beam unit, percentage depth dose. I am giving a very good clue. This answer has to be the C, because the output factor and the output, you will easily catch that. Rather, I would rephrase it and say the relative dose factor is measured in the same reference geometry and depth as that used for measurement of backscatter tissue output. Unless he knows the relative dose factor is a factor for output, he won't be able to catch this answer. And he must be actually knowing the learning outcome that I expect in this. So this type of clue you should not give in your STEM itself. Let us go to the alternatives. We looked at the STEM now. Let us look how the option should be. This will have one correct answer. We should make sure that it is only one correct answer. If it has multiple correct answers, then you use the multiple answer type I gave you earlier. But there has to be one correct answer or the best answer, we should say, right? And a few distractors, wrong options. It is more important to have distractors that appear like the correct answer. Then only the student who has understood the learning objective that you are expecting can answer the correct one. The others will, the person who has not understood the science behind your question will not be able to answer. So the distractor should appear as plausible solution to the problem for students who have not achieved the competency level expected. Avoid unrelated, implausible, and unconnected options. I'll give you examples for this. Then the other thing is repetition of same phrase. This is a very simple thing. Probably we don't do this. For example, in this question, if you see the stems have all the alternatives have the same starting thing. On the inner surface, on the outer surface, on the inner surface, on the outer surface. Sometimes you will have 2, 2, 2, 2 or something like this. So this can be taken to the stem itself. This on the could be here, and then you say inner surface, outer surface, inner surface, outer surface as a continuous statement. So you can, instead of avoiding repeating the same thing, this is just to make it look good, right? All alternatives should be plausible. By which, what I mean, this is a good example. I'm taking the same example again. The incorrect alternative should serve as a distractor. He should, unless he knows the correct answer, he should not be able to guess the right answer. Should be selectable by a person who did achieve the learning objective. Only the person who has known the answer, note the science behind your question, will be able to answer. For example, I asked the same thing. I like the statement, the energy of Bremsstrahlung X-ray beam is denoted by applied voltage and not keV because the Bremsstrahlung beam is polychromatic, it's monochromatic, it does not have an electron in it. So this is a distractor. because he will look at KV and think that it is because of electron. If he hasn't really does not know the answer, he will take that electron there. So this is what I mean. Your alternative should be as plausible as possible. And alternative should be stated clearly and concisely. Don't have your alternative a long one. To give an example, suppose you are asking percentage depth dose. Don't give 5 different definitions of percentage depth dose, which will run into 2-3 sentences. Like for example, percentage depth dose is a ratio of dose at depth to a D to a small mass of tissue to the dose at Dmax to the same mass of tissue expressed. This is will make the student confusing. It will be confusing for the student. Make it and concise, as small as possible. Alternative should be homogeneous in content. Don't have a heterogeneous answer in the place of a homogeneous one. I give you an example. This is something which actually I said it, then I realized when I was doing it, what I did was wrong. The following are the issues with superficial X-ray therapy, except if you look at this, you will easily catch this is the wrong answer, which is the right answer. Because it is negative, it is the wrong one, right? So it is the right answer. So here it says short focus to skin distance and hence large influence on inverse square law. Calibration difficult due to strong dose gradient. There is some substance in it. Photon beams may be contaminated with electron scatter. And here I am saying simply can be used to treat 0.5 centimeter. So naturally, easily people will catch. So this type of non-homogeneous alternative should be avoided. And alternative should be free from clues about which response is correct. Here I'm giving another thing where I'm talking about clue. The geometrical penumbra depends on the following except source to diaphragm distance, source to skin distance, beam energy, source size. If a person looks at it, he will know 1, 2, 3, and 4 have the source. This is the only thing which is a little different. So this must be the correct. Of course, that is the correct answer. If a person who knows the science will tick this. But rather, I would put it differently. I would say geometrical penumbra depends on the following except radiation source to diaphragm distance, radiation source to skin distance, radiation source energy. Instead of just saying beam energy, which will look as an odd man in, he will select that. Here, I don't make it like an odd man in, try to make it a little more homogeneous here. Alternative should be free from clues about which response is correct. Here, there are, apart from the clues I told you, there could be other non-scientific clues, I would call it. One is your grammar sometimes can be tell what is the right answer, the grammar that you used, or the sentence formation that you had, the phrasing can tell what is the right answer. To give you an example, for example, here I'm saying the wedge factor is required in the calculation to correct the beam output. So to follows correct the beam output is a good sentence. It is a correct sentence. Suppose you add the sentence with B, the wedge factor is required in the calculation to as radiation beam. The English itself is not right. So he will easily eliminate this. Now your option becomes only 2. So your sentence, the phrasing, the English should be correct. Right? If you make something slightly different, then he will catch from that difference itself that this is not the right answer. Again, the grammar. The effective SSD method for correction of patient contour shape and irregularities uses and I say, and then I use K factor here. So and cannot be followed by K as per English grammar. So people will immediately remove this. And and will not follow a ratio. He will remove this. So you have to be very careful with the grammar also. That should not give a clue. Right? So here it is the only correct answer he will easily choose and follows inverse. Even if he doesn't know the science behind it, he will still choose this. The most important thing I would like to say, which we most often tempted to use, is all of the above or none of the above. What is the problem in giving all of the above? When all of the above is used as an answer, test takers can identify more options than one alternative as correct, can easily select the correct answer. What happens is you have got, let me say 4 options and you say all of the above. He knows there are 2 things correct. Then he knows the all of the above is the correct. he need not worry about the third one at all, right? Even if it is little plausible, he will choose the last one. And similarly, if there is one incorrect answer, it will also guide him easily to get the exclude all of the above, because he knows there is one thing which is incorrect. So all of the above also is incorrect. You are now done with two options are gone. Only you have two options for the student. Then it will go like you are, Kaun banega crorepati, 50-50. He will choose one and he may get it. Similarly, the same thing with none of the above also. He will, the same argument. If you put none of the above also, it is easy to exclude one of them. So totally avoid in our thing all of the above and none of the above. Present option in an alphabetical or a numerical order. You have to have an order if whenever you are using a particular statement or numbers. I'm giving an example. Here, the student will easily catch the first one is the correct answer, because that one is totally different from the way I have given the rest. So he will easily catch it. But when you do a computer-based one, it gets shuffled. But when you do a printed one like our CMPI, please avoid having something like this. It will, giving a clue, this is the right answer. And you should not twist the candidate by putting it this here and then having something. Then you are not really, trying to do the right one. So put it in one order so that the student concentrates only on the testing objective. Do not use absolute options, like never say, never measured at Dmax. When you give some swearing sentences, then it becomes like the student will get it. Okay, this is the more important. He's using never, so that has some meaning. And student will leave out the science behind it, will start looking at the way you have framed the question and try to answer from them. So usually measured at 10 centimeter. So these are the things you have to avoid. Avoid usually, avoid never, all these in your question formation. Let me conclude. Anyone can write an MCQ. This I actually borrowed from somebody. It's not mine. Don't scold me if you don't like it. But writing a good one that accurately tests a piece of knowledge and the student's ability to apply, it takes a bit of more thought process. You have to spend your time. That's why we are saying do 25. You take time and spend your thought process and do it. Take time to ask yourself, what do you want to test from the student? What, by having this question, what am I testing? What is the learning objective, learning outcome from this? And construct the question accordingly. It is difficult to construct a question, but easy to score, right? Once you know that, you can easily do the scoring. So the question should be done very carefully, taking into account whatever we discussed now. And if you have any other questions, I will be happy to answer. Before that, when I say happy to answer, the disclaimer, I'm not an expert, but I'm just trying to bring in some standard in CMPI questions with Jamima. So that's what we are going towards. And we need to keep on improving, right? This is only a first step towards it. And I have made some guidelines here. Now in the discussion, we can add or subtract the guidelines for setting the questions.